sometimes we just ought to be a little bit honest. It's quite a distance we've covered from where we started off. We started off from the introductions, and we've just covered the part of sketching functions. Now, at this stage, I believe you are more than competent with sketching a straight line function. Now, we are going into a situation where you are now given the sketch of a straight line function and being asked to determine the equation of such a graph straight line function. So let's look at this example in here. In this example, they say determine the equation of the following graph. So in this graph in here, we have a graph that is increasing from left to right. So with that in mind, according to the slope of this graph, it says to me the gradient is positive, seeing as it's increasing from left to right, right? And then we also have what? 2 points on this graph. We have got this point in here, and then we've also got this point in here. So in this point in here, this -2 would represent our x, because we know that y is 0 anywhere along the x-axis. At this point in here, y is 0. Just as in this point in here, we know that this 4 represents the y, seeing as x is 0 in here. So in truth, our points are 0 and y is 4 at this point. And in this point in here, x is -2 with y being 0. So we've got 2 points on a graph. When you've got 2 points on a graph like this, then you ought to be reminded of the steps that go into determining the equation of a function. So when we are determining the equation of a function, our first step is always to calculate the gradient. After we calculate the gradient, we determine the value of c in that standard form of y is equals to mx plus c. After we got both the gradient and the c, we just substitute m in the place of m in this equation and c in the place of c. Simple enough, ne? So let's go into a practical sense of applying these steps. First off, we've got 2 points on a graph. Our first step is to determine the gradient in the standard form of y is equals to mx plus c. So in order for us to determine our gradient, we remember our formula for gradient, which is changing y over, this is y1, y2 minus y1 over x2 minus x1. This is our formula for the gradient. This is the same formula that you've been using in grade 9 and 8, I believe. So let's go at it. So I'm just gonna go on a limb and give my points labels. So I'm gonna label this point in here as my first point. So this is point A, and then this is point B. So why am I labeling them? This is to say this is my point 1, this is my point 2, so as not to make mistakes as I am substituting into the equation. So after writing the equation, now I'm just going to substitute this point into the equation. So the equation says y2, this is my point 2. At the second point, what is my y? Y is 4. And then the equation says minus y1, minus y1. What is my y1? Y1 is what? 0. So y2 minus y1 all over x2 minus x1. What is my x2? I am going back to my point 2. The x coordinate of at my point 2 is what? 0. So it's 0 minus what? x1. x1 is what? Now note that the formula has a minus of its own, so I'm writing the minus from the formula and then I'm substituting my minus 2. From there, I put everything in the calculator as is. Then I punch in, it's gonna be 4 divided by positive 2, which is then gonna give us positive 2 as our gradient. Is this positive 2 correct? Yes. I was already expecting a positive gradient, seeing as the sketch is increasing from left to right. So this simply means if we had gotten a -2 or any form of a negative answer in here, that would be an immediate indicator to us that something is cooking after baking and something smells fishy, seeing as we are anticipating to get a positive gradient, given that our sketch is increasing from left to right. Now the information, needless to say, applies vice versa in a situation where the sketch is decreasing from left to right. So come back to our steps. Our first step was to calculate the gradient. We've done that. Now our next step is to determine what? The value of our C. What is then the value of our C? Let's go and find the value of our C. The value of our C. To find the value of C, I am going to say y is equals to mx plus c. But I already know that my m is 2 mus. So I'm going to say 2 here. Here we get it. X for the x and then c. Now remember that this the c in the standard form of y is equals to mx plus c always represents where the graph cuts the y-axis. So for those of you that already know that, we already know that our c is going to be 4. Ne? But I'm gonna go at it with an assumption that you've forgotten about the fact that c represents where the y cuts, where the graph cuts the y-axis. I'm gonna go at it with an assumption that you've forgotten that piece of information and you are just now looking for your c. If you've forgotten that and then you've already determined your gradient, this is another way of finding your c by using any point you know on the graph. By the point you know, I mean the point whose coordinates you both know, meaning you know both the x and y coordinate of such a point. So which points do we have? We've got point A in here, I mean point B and point A. So for simplicity's sake, I'm gonna go with point A, but you can use either one of these points to determine C. I'm gonna substitute the point that I know to determine C, any one of the points that I know. So in point A here, the y is 0. So in the place of y, I'm gonna substitute 0. 2 is still a 2, and then x is what? Negative 2 in this point. So I'm just going to substitute negative 2 plus c. Negative 2 times negative 2 is going to give us a negative 4. So I'm going to transpose the negative 4 to the other side of the equal sign, which is then equals to c, which then means therefore our equation for this graph y or f of x is equals to mx, for which our m is 2x plus c. Our c is what? 4. When we've done this, we've determined the equation of our graph. Any reports or questions whatsoever? If you've got any questions whatsoever or anything you'd like me to clarify or expand further on, please be sure to hit me with the I don't know, suggestions or the questions in the Q&A sections and the comment sections below. You are most welcome. Like I always say, I don't mind answering the same question 50 times because you understanding matters a hell of a lot more to me than me doing one thing only once. So thank you very much. There's gonna be another example in the next video that will be specifically dealing with finding the equation of a linear function when you are given 2 points on a graph. Right? So just in case that you guys didn't actually make sense of what I discussed in here, so be sure to check out the second example on this. Thank you very much. See you in the next one.